Okay, ladies and gentlemen, let's get ready for today's video lesson. So today, the topic that we are going to be discussing, and let me just start sharing my screen so we can look at some of the examples that we're going to see in this video. Um, so the topic that we're going to begin discussing today is graphing systems of linear inequalities. Now, before I get to the examples that we're going to see in your textbooks, I want to review a little bit of how you would graph a linear inequality. Now, we've only seen graphing linear inequalities on a number line. So we've only seen graphing linear inequalities like this, horizontally, right? But what we are going to begin to see today is not just graphing linear inequalities horizontally, but also vertically. So for example, let's take a look at this. If we were to graph this equation, x is less than 3 on a horizontal number line, all we would really do was say, well, we would plug in the numbers and say, well, 0, 1, 2, and 3. Now it's saying that x is less than 3. And x being less than 3 on a horizontal number line would say that our answer is basically any number that is smaller than 3, and we would graph our inequality like this, right? We would just draw our ray moving to the left because basically x would be any number less than 3. But we're not going to see it in terms of a horizontal number line. We're actually going to see it in terms of a vertical or a coordinate plane, which means that this is going to vary just a little bit. So how would I graph this if instead of using a horizontal number line, I would actually be using a vertical or a coordinate plane? So let me go ahead and just do that real quick. So we're still looking at this one right here. We're still looking at x is greater than or less than 3, but we're going to do it on a coordinate plane. So let me draw my y as the other part of the coordinate plane. And one thing that we want to do is if we were going to graph this inequality, if we're going to graph this inequality on a number line, one of the things that we want to do is change that x is less than 3 to x is equal to 3. And the reason we're going to do that, and I'm actually going to write it in a different color, is so that because we know how to graph a line of x on a vertical on a coordinate plane. We know how to graph x equals 3 on a coordinate plane. So what that means is I'm going to look for 3. It's positive 3. So this would be 1. This would be 2. And this would be 3. Now, if I was going to graph this, saying that x equals 3, what that is, if I were to graph that, is basically a horizontal line, right? A horizontal line, because basically it's telling me x equals 3 and y would basically be any number, but x is always going to be 3. So again, what I'm trying to say is that if the graph says x equals 3, that means that x is going to equal 3 and y is going to basically be any number. Now, I know that there's going to be a horizontal line drawn here at x equals 3. But we have to remember that we're not graphing x equals 3. We're graphing x is less than 3. So I know that if I were to graph x equals 3, I would leave that horizontal number line like that. But since we are looking at an inequality, and the inequality is in fact telling me that x is less than 3, it's not saying x is less than or equal to 3. It's saying x is less than 3, which means that this horizontal number line, which is drawn here, is actually going to be a dotted line. So let me go ahead and do that, a dotted line, because it's saying x is less than 3, not x is less than or equal to 3. So this is going to be a dotted line. Now, because it says that x is less than 3, um, if I want to graph this inequality on a coordinate plane, because it's saying that x is less than 3, what we do is we shade these numbers in. And shading these numbers in just gives us an idea on where that answer is going to be. So I'm actually going to use a green shade, and the green, and I'm not going to shade them, I'm going to draw arrows to indicate that what x is less than 3 means is that whatever possible answer I'm going to have is going to be an answer that is smaller than positive 3 without including positive 3. Because positive 3 is not included, we simply draw that as a dotted line. Now, it's very simple. And again, I'm introducing this or reviewing this because when we see graphing systems of linear equation, these key concepts are very, very, very important for us to understand. So that's pretty much how we would graph the function x is less than 3. We would simply shade in the anything that is to the left of 3. But now let's look at the second equation, or the second inequality. I'm sorry. The second inequality is saying y is less than negative 2. So again, I'm going to do the same thing I did, which is change that y is less than or equal to negative 2. And I'm going to change that into y equals negative 2. And the reason I'm going to change it into y equals negative 2 is because I already know how to graph a function when y equals negative 2, because we talked about this when we were working with linear functions way back when in, I believe it was chapter 1. So let me go ahead and draw the coordinate plane down here. And I know again that y is going to equal negative 2. So if y equals negative 2, I'm not going to have a vertical line like I did in the other one. I'm actually going to have a horizontal line. So the first thing I'm going to look for is negative 2. And if I graph my inequality, I know that negative 2 is down here. So negative 1 and negative 2. Now what I'm going to do is I'm going to draw a horizontal line. Now, and I want to highlight this before I actually do the graph. In the first one that we saw, y is less than 3, or x, excuse me, is less than 3. We know that that's basically telling me that x is always going to be 3 and y is going to be any number. But because x is less than 3, we drew a dotted line. Now, in our second equation, it's saying y is greater than or equal to negative 2. And because y is greater than or equal to negative 2, that's saying that negative 2 is part of the answer. So I am not going to draw a dotted line like I did in the first uh, inequality. I'm going to draw a line that is not dotted, a filled in line, because what that's saying is that 2, or negative 2 in this case, is part of my answer. So we draw our line, negative 2. Okay, negative 2 right here. Okay, now what's going to happen now is that now that I know that y is less than or equal to negative 2, I can now, or y is greater than or equal to negative 2, now I know which sides I'm going to shade. Now, because this inequality is saying that y is greater than or equal to negative 2, I am actually going to graph everything above negative 2, okay? I'm actually going to graph everything above negative 2. I'm going to graph everything above negative 2. Give me 1 second, ladies and gentlemen. Seems to be having a little bit of technical issues here, so give me a second. Okay, so I'm going to basically graph everything above negative. I'm shading everything above negative 2 because it's saying that y is greater than or equal to. So here we go. So again, I'm going to shade everything above negative 2. Here, it said that x was less than 3, so I shaded everything to the left of 3. But because it's saying y is greater than -2, I'm actually going to shade everything above -2. And again, I'm going to use the green, and I'm not really going to shade it. I'm just going to draw the arrows. And basically, these arrows are indicating to me that the answer is going to be any number that is above -2 in this case. All right. So that's how we do them individually. But how do we work when we have a system of linear inequalities, which is what we're going to see now in the next 3 examples. So we're going to see 3 examples in which we have 3 systems of linear inequality. So how does that work? So the first thing I'm going to do is I'm actually going to go ahead and erase this. If you have any questions with what I did, you can always pause and rewind the video. Okay, I'm gonna simply just erase this. I'm gonna erase everything down here, and I'm actually gonna leave this inequality. I'm gonna erase parts of it. Hopefully I can just kind of add to it without having to, let's see. So, okay. So I am going to add to it and make it a little bit longer vertically, and also expand it horizontally, and that way I can have more space to add any possible answers. And let's see if I can do it here as well. All right, now let's see if I can move this bar a little bit so I can have some more space to expand here as well. And now I can go ahead and graph these inequalities. So the first system of inequalities that I have is this one. X is less than or equal to -1 and y, or excuse me, x is greater than or equal to -1 and y is less than +2. Okay, so let's go ahead and do that real quick. So that way we can work with that. So give me 1 second, ladies and gentlemen. All right, let's go. So let's look at each. Let me use the blue color so that way I have a consistent pattern. Let's look at y equals -1. So y, or x is greater than or equal to -1. Let me go ahead and just kind of, let me actually see if I can have a little bit more space here and be able to spread those coordinates a little bit wider so that when I graph everything. Now we're going to find a solution to this system. And this is a little bit of a combination of what we were doing, which was graphing inequalities on a coordinate plane, but also a little bit of solving systems of equations by graphing. So let me go ahead and let me see if I can expand a little bit more on the number line here, on the x-axis to be exact or specific. And let me do the same thing here. So x is less than or equal to -1. The first thing we're going to do, again, this is an optional step. You can just change that into x equals -1 if it'll help you graph, although honestly, it will not make much of a difference. X equals -1. Now, I know that when I graph this inequality, because x is greater than or equal to -1, I know for a fact that what that means is that the line that I draw is not going to be a dotted line. It's going to be a line, a full line. So -1 is here. X is -1. And that means that x is always going to be -1. If I look at it in terms of x equals -1, that means that x is going to be equal to -1. However, the y coordinate is going to vary. So x equals -1. And because the line, because the inequality, because it says it's greater than or equal to, that means the -1 is included in the answer. So I graph my line, my vertical line to be exact in this case, without dotting it, because x is greater than or equal to -1, suggesting that -1 is part of the answer. So I have this here. And again, it's saying x is greater than -1. This inequality is saying x is greater than -1. So that means that I'm going to shade everything to the right. Now, I'm not really going to shade. I'm just going to draw arrows. And that suggests that the arrows are, in fact, indicating that everything to the right of -1 is a possible answer. So everything to the right of -1 is a possible answer. So that's why I shaded. And I'm using different colors. And the reason why I'm using different colors is to distinguish. Now, how do I know the answer to this system of linear inequalities? Well, I know the answer because when I graph my second inequality, there's going to be a point in which the shaded colors are going to meet. And that will indicate the possible solution. That's why I said it's a little bit like graphing inequalities. So now let's look at the second one. Y is less than +2. So what I'm going to do now, and let me use a different color. Let me use green for this. So +2. So this would be +1. And this would be +2. And that means that this is going to be where I'm going to graph that point, suggesting y is going to be +2. But it's a dotted line because it says y is less than +2, indicating that +2 is not part of the answer. So we're going to graph that dotted line. And we're going to graph the dotted line as well. And let me draw our arrows, explaining that a line extends infinitely in both directions. Now, what that means, ladies and gentlemen, is that I'm going to shade everything below +2. And when I start doing that, I'm going to realize that there's going to be some regions that are actually going to intersect the fuchsia arrows that I'm drawing with the red arrows that I drew, suggesting that there's going to be a point or somewhere where these lines are going to intersect. And if you notice right here, is the region where I have the red line and the red arrows and the pink arrows or fuchsia arrows intersecting. And those regions where you see the colors, in this case of the red arrows and the colors of the fuchsia arrows combining. So again, guys, that just indicates, and we can take test points to try that out, but it'll be the same. If you notice, again, the arrows, I only drew one arrow, but obviously it's because I don't want to shade in the whole thing. But pretty much it's in these regions right here that you're going to see the where whatever the solution is going to be located. So it's going to be right in these regions. And that's pretty much how you solve a system of inequalities pertaining to or graphing linear inequalities. We're going to see another example in a minute. And we're going to see in that case is how you do it. So you can go ahead and you can pause the video if you feel more comfortable. And if you do, you will see you can appreciate a little bit more where the answer is. Again, the answer is in the regions in which the lines are actually connecting to each other, and And what I'm going to do is I'm actually going to go ahead and shade it so you guys have an idea in a different color of where the answers are. Okay. So what I'm going to do, just to distinguish it a little bit better, is let me take these little red arrows and expand them a little bit more, as well as the so this area right here and this area right here as well. And let me go ahead and illustrate that a little bit better to avoid a little bit of confusion here. So what I'm gonna do is I'm gonna extend that. Okay, so I know everything to the right, which indicates all this right here. And as you can see, the fuchsia lines that I drew down here are basically intersecting or intercrossing the red arrows. And what that indicates is that it's in this region where the answer, any ordered pairs in this region, is where the answer to this system of equalities. Now we don't have to give a specific answer to them. Don't worry if you're like, okay, so what number do I use? You don't have to. All you need to know is that in the regions in where the shaded colors, in this case I use the pink arrows for the y is less than 2, and the red arrows for x is greater than or equal to -2. And so basically, to use a different color, where my answer would lie would be in this region right here. So what I'm going to do is I'm going to use yellow to indicate the regions where this answer is true. Okay. So it's in this region right here that the answer to the system is. Again, you don't have to give a specific answer. You don't have to give a specific order. You could use test points, and if you look at other videos or other books, they use test points. But so you guys have a general idea. That's pretty much what we're gonna do. So let's look at the other examples real quick. The other two examples, and erase this. Hopefully, I don't eliminate the entire number line. Give me a second, guys. Okay, so now we're going to look at our second example. In our second example, if you notice, we don't have just one small inequality, but we actually have um, graphs that have slope and that have a y-intercept, and that can very rightfully so cause a little bit of confusion for some people. But the reality is that is a relatively easy procedure. It's very similar to the one that we just did. So you guys can listen to my soothing voice while I erase this, hopefully without erasing the graph, and we can recycle the graph or the coordinate plane. I'm sorry. And let's go ahead and delete this right here, and delete this, and this. Okay, so now I think we're good. Let's look at that other example. So the second example that we're going to see, and again, whenever you're graphing systems of linear inequality, we use different colors to distinguish the possible answers, and our answer is going to be that point in which those two colors kind of mesh together, right? So let's look at this equation, right, or this inequality right here. It says y is greater than -2x minus 5. Now, if you notice, we have -2x, which is my slope or my rise over run, and we have our -5, which in this case would be our y-intercept. So the first thing I'm going to do is I am going to identify my y-intercept, or my b, which in this case is right here, and that means it's going to be 0 and -5. So that means that that is going to be the first ordered pair I am going to graph. And we have our slope right here, which is -2/1. That means rise over run. So that means that I can do it two ways, either two spaces down and one space to the right, or one space to the right and two spaces down. Either way, it's going to give me the same answer. So the first thing we're going to do now is just graph them. So 0 and -5. So let's go ahead and try to expand our ordered pair, or give it enough space so that we have a clear idea of what we're doing in terms of this. Let me see if I can expand it a little bit further down vertically. And okay, so that should give me the other ordered pair that I need, 5. So 0 and -5. And we're going to do this just like we've graphed all other linear equations. Nothing is going to change. So 0 and -5 is down here. So we can do this in two ways. And let me see if I can move this bar a little bit over here so that way it doesn't. We can do this in two ways. We can do this in two ways. So we know that our ordered pair is 0 and -5. And what I can do is I can go two spaces down and one space to the right, giving that the slope is -2/1. So I can say 1. Let me see if I can expand that a little bit more and work on it. So I can do it two ways. Now I can do it two spaces down and one space to the right, or I can just do, which is makes more sense in this case, one space to the right and two spaces down. So that would be 1 and 2, meaning that the other ordered pair is going to be down here. Now, why did I choose to do it one space to the right and two spaces down instead of, the opposite? Is just because it's just in terms of being able to create more space. But if you want to do it two spaces down and one space to the right, it's going to give you the exact same coordinate regardless. So I did one space to the right, two spaces down, and this is my second order pair. Again, if you decided to do two spaces down and one space to the right, you're going to get the same answer regardless. I just want to clear that up for you guys so that it doesn't create any confusion for you. So go ahead, and I'm actually going to see if I can continue to expand on this and be able to move a little bit further down the line, at least one more ordered pair. So again, if I'm deciding to move, I'm going to move one space to the right here and then two spaces down. So this would be 1 and 2. And that means that the other ordered pair would be here, and that's approximately at 3 and -8, if I'm not mistaken, -9. So, and I'm going to leave it at that because I don't have a lot of space and I don't want the points to look scrunched up. So I graphed the first line. Now it's going to be a dotted line. And the reason it's going to be a dotted line, guys, is because if I look at this inequality, it's saying y is greater than 2x minus 5. It's not including it. So it's going to be a dotted line. And I'm going to use red for it. So this is going to be a red dotted line. And it's going to continue down here. A red dotted line. Okay, so you guys have an idea. It is going to go, or it's going to intersect or cross the different points, but it is a dotted line because, again, it says y is greater than, but it is not including it in part of the answer. And I'm going to go ahead and continue to extend this graph. Okay, so this would be the first function, y is greater than 2x minus 5. Now, I want to see the possible answers that I have in this case, and basically the inequality is greater than. So that means that the answers to the first one, to the first part of the system, y equals is greater than 2x negative 2x minus 5, would be anything to the right of the equation. Okay, so I'm going to see if I can draw those arrows bigger or longer. Anything to the right. Anything to the right is going to be an answer for that inequality. Okay, now we're going to do the same thing, but we're going to look at the second inequality. And we have the same situation. We have a slope and we have a y-intercept. Now, y is less than or equal to x plus 3. So in this case, our intercept is at the point 0 and positive 3. So 0 and positive 3. And 0 and positive 3. And our slope in this case is m equals 1. So that means that our rise is 1, which is our y, and our run is also 1. So the first thing I'm going to do is I'm going to graph that ordered pair, and I'm going to go ahead and use red for that. So we would have 1, 2, and 3. Now it says y is less than or equal to positive 3. So, and the difference is that this is not going to be a dotted line. It's going to be a full line. And the first ordered pair is 3. Now, our slope is rise over run. So you can go one space up. Let me see if I can move this bar to the other side. And that way I have enough space to work with it. Hopefully this will provide me the space that I need. So I can go, again, 0, 3, I can go one space up and one space to the right. So that would be here. And I do the same thing, one space up, one space to the right. And that will be here. And again, from this point, one space up and one space to the right. And so on and so forth. So this is going to be a full line because it's saying less than or equal to. Less than or equal to. And let me just move this here. And this means that the graph is going to extend infinitely. As well as our, and to illustrate the point, let me just continue to draw that dotted line as well. Actually, you know what? Let me use a different color for this, so that way I can illustrate the point better. So let me undo some of this, and that way I can use a different color. I'm gonna use a light blue, and that way that will illustrate my point a little bit better. So I know that this is the line for the equation y is less than or equal to x minus 3. And I am going to expand that graph infinitely, because remember that a line expands infinitely in both directions. Likewise is true, the same is true for the equation here. And to continue with what we were saying, everything to the right of this equation is part of my answer. And if I look at, so that continues to be true. Okay, that continues to be true. And what's going to happen is that in the case of the other graph, which is the y equals, or y is less than or equal to x plus 3, that is also going to continue. So basically, y is less than x plus 3 means that I am going to pretty much graph any coordinate below 3, because it's saying y is x is less than or equal to x plus 3. So that means that my answer is going to be, and let me use the fuchsia again. That means that my answer for this graph is going to be at any point that is smaller than 3 in this case, because it's saying x plus 3, so smaller or beneath positive 3. And if you notice, the graphs are actually going to intersect, and let me draw those arrows a little bit longer, somewhere in this region. So I continue. So that means that x is going to be at any point at smaller than positive 3. So that means that on this side, the graphs are not going to intersect. Let me, where I'm right here, at this point right here, the graphs are not going to intersect, because it's saying that x is less than positive 3. Had it been negative, that would have been a different story. So that means that the answer is going to be in this region right here. And I'm going to shade it in a different color so we understand. So basically the answer, the ordered pairs that would make that statement true, are going to be in this region here. Okay, now so far we've seen systems of linear inequalities that have an answer, but sometimes you have systems of linear inequalities that do not have an answer. That means that the lines will not intersect, or the possible answers for those lines will not intersect at any given point. And that's the example that I want to show you guys. So hopefully this will clarify any doubts that you guys may have. Give me a second. Clarify any doubts that you guys may have. Hopefully I'm able to delete these coordinates without deleting much of the graph. Or the coordinate plane, I mean. So again, this is not that difficult. It can be a little tricky, but all you guys need to do is kind of practice. The good thing about this video is you can always pause or rewind it if you have any questions. And of course, if you need to contact me, you guys know where to find me. And I'm always at your dispositions to clarify any doubts. Now let's look at the last example of this video. And let's look at the system of 2x plus 3y is less than 6 and y is greater than or equal to negative 2/3 x plus 4. Now, let's look at this equation real quick. Uh, and what I want to let you guys know is that this is not solved for y. So I want to solve it for y in order to be able to have the system that, or to be able to graph it in the coordinate plane. So the first thing I want to do is get rid of this. So that means that I am going to first solve for y, and I have the system 2x plus 3y equals 6, plus 3y equals 6, or is less than 6, I'm sorry. Now, what you can do if you're going to solve for y is you can rewrite this equation, and instead of writing less than 6, you can say equals 6. And the reason you can do that is so that it's easier for you guys to work with. Although you just have to remember that at the end, you have to write the inequality sign because they are linear inequalities. So if I'm going to solve for y, the first thing I'm going to do is get rid of this 2x. And that's going to leave me with 3y equals 6 minus 2x, because I subtracted by 2x on each side, or I move the 2x to the other side. So 6, let me just show you what I mean. So you subtract 2x here, and you subtract 2x on the other side as well. So you subtract 2x, and what that's going to cause, or that's going to do, is it's going to cancel out on this side, and that would be 6 minus 2x. And the last thing I want to do is divide by 3. And then just rearrange my equation. So I'm going to divide by 3. And that would be y equals, and 6 divided by 3 is 2. And 2. So this is going to cancel out. Always making sure that you follow all the rules. And finally, you're going to have your system. Now remember, it's not equal to the reality. It's that it is less than or equal, or in this case it's actually less than. So we have our answer being less than y is less than negative 2/3 x plus 2. 2/3 x plus 2, because 6 divided by 3 is 2. Now that I have that, let's actually go ahead and graph it. So now that I've solved my equation for y, let me erase all this. I've solved my equation for y, and I get it. Y is, I'm sorry, not less than or equal to, I apologize. Y is, let me fix that. Y is less than 2/3 x, or negative 2/3 x minus 6. Negative 2/3 x minus, or plus 2, because 6 divided by 3 is 2. So now that I have it solved for y, I'm actually going to go ahead and graph that inequality first, and then graph the other one to see if they do have a solution or if they do not. So let's go ahead and graph that now that I have my inequality, in this case, solved for y. And let me box that answer in. This is the answer that I got when I solved the first inequality for y. So this is what I'm going to graph now. And this is the answer that I got once I solved the inequality for y. So let me go ahead and graph that. And it says y is less than negative 2/3 x plus 2. So I'm going to graph the first ordered pair, which is 0 and 2. And let me delete this. Let's see. So 0, 2 is the ordered pair that I'm going to graph, and I'm going to continue to use red. And that would be my y-intercept, which is right here. Okay, so this is where I get the 0, 2 from, because this is my y-intercept. 0 and 2. Now my slope, which is my rise over run, is this one. And it says negative 2/3 x. So that means it says this is my slope, and it says negative 2/3 x. So what I can do is I can either go down 2 spaces and move 3 spaces to the right, or I can move 3 spaces to the right and go 2 spaces down. However I feel more comfortable. In this case, I'm just going to go ahead down 2. So this would be 1 and 2, and 3 spaces to the right would be here. Sorry, at 0, 3, which is right here where I'm trying to graph. And then I'm going to do the same thing. You can go down 2 spaces and then 3 spaces to the right. So this would be 1, 2, 3, and that would be about here. Actually, here. And then you can do the same, and then 2 spaces down and 3 spaces to the right, and that would be about here, more or less. So we're going to leave it at that. And then I'm going to actually go ahead and do the other graph, which again, 0 and 4. So 0 and 4. And of course, it says that y is less than or equal to. So y being less than or equal to means that all the possible solutions for this, first of all, the graph is a dotted line. It is not going to be a full line. So let me go ahead and draw write down the dotted line real quick. And this one, and then that means that if it's less than negative 2/3 x plus 2, that means that the answer is going to be anything to the left. So that means that the arrows would be going to the left, all the way to the left, all the way to the left here as well, all the way to the left. And now we're going to draw our second graph, which is actually y is greater than negative 2/3 x plus 4. So here we have our ordered pair is 0 and positive 4, because this is the b, and that means that the y-intercept is at 4. So the first thing we're going to do is we're going to graph that, and then we're going to do the same thing that we did for our previous graph, which is noticing that my slope is also negative 2/3 x. So that means down 2 spaces and 3 spaces to the right, but starting at 0, 4. So 0, 4 is here. And again, 2 spaces down, 1, 2, and then 3 spaces to the right, we 1, 2, and 3. And I do the same thing, 2 spaces down, 1, 2, or excuse me, 1 and 2, and then 3 spaces to the right, 1, 2, 3, and that would be here. And it would be the same thing, 2 spaces down, 1 and 2, and 2 and 3 spaces to the right, so it would be here. And so on, 1, 2, and 3 spaces to the right would be about here. Now the difference is that the second equation, which is what I'm drawing in blue, says greater than or equal to. So that means that this is not a dotted line. This is a full line. And we're not going to draw a dotted line. We're actually going to connect all the points. And that would be our equation, our inequality, in this case. And then we have our arrows going infinitely. And let me draw the arrows here, and I just realized I didn't draw it for the other one. So let me go ahead and do that as well. And let me go ahead and get the red. And we have a dotted line here. So we didn't draw a line or our arrows. We're drawing our arrows here as well. And as I was saying, now it says is greater than, the second equation says is greater than or equal to. So that means that not only is it a full line, but everything is to the right. So if everything is to the right, that means that our answers are gonna be everything to the right in this case, right, or above 4. in this case. Uh, Remember, greater than usually means right, less than means to the left. So we're going to use, you know what? I like the fuchsia color today. So let's use the fuchsia color. And that means that we have our graphs going upward. Now, if you notice, the answers are in two different positions. And what makes them that is the 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 inequality signs, because in the first equation, even though they're both positives, it's saying that is less than, and less than would just indicate that the arrows go to the left down here, and the greater than indicates that the arrows would go to the right or above the y in this case. Okay, so ladies and gentlemen, hopefully this video will help you guys have an idea of what to do for the lessons. If you have any question, you guys know where to find me. So stay safe, and we will see each other very soon. Bye.